Dear friends, in the continuation of learning gas turbine technology, so we have discussed in the previous class, we have discussed about heat exchange cycle. So in this class, we will just see the continuation of that heat exchange cycle. That means we are in this class, we are going to discuss the certain performance parameters, or okay, based on performance aspect, we will discuss certain things. And also we will see the how the efficiency curve varies with respect to the pressure ratio, and also for the fixed that temperature ratio, how it is going to vary. So we'll discuss in this. So first of all, yeah, we have seen how the heat exchange cycle works, and also we have got the formula for efficiency. Okay, so and then final formula, finally we got the output. Okay, so output is okay, so efficiency equal to 1 minus C by T. So and also we have discussed about how the perfect heat exchange occurs or takes place. So then based on this condition, the perfect heat exchange occurs. So then now based on this performance, that means based on the efficiency formula, how the performance is going to affect or going to be decided. So first of all, the performance from the efficiency formula, we can understand one thing. So this formula, that means efficiency, the thermal efficiency is not depends on only on the pressure ratio, because our C is nothing but we know C is equal to Rp power gamma minus 1 by gamma. So this is C, and T is nothing but T3 by T1. So yeah, so that means this efficiency is not only depends on the this pressure ratio, means the C. So it depends on the this temperature ratio, particularly if you want to say it is depends on the maximum cycle temperature, because this maximum cycle temperature determines the performance. Okay, so that is very important. So if the maximum cycle temperature increases or decreases, so based on that T also will be varying. So based on that this efficiency also will be varying, how it varies. So whenever we say the T is okay, say now let us say that C is fixed. Then what happened to the efficiency? So if the C is fixed, the T is increasing. Let's say that T is increasing. If T increases, then what happened to efficiency? If the T increases, the whole ratio decreases. That is the idea. Because the C is fixed, then it is increasing. So say for example C is 2, then T is 5. So or T is 4. So if T is 4, this is nothing but 0.5. So then if you increase the 0.5, means the efficiency becomes 0.5, 50%. So then suppose if you go for this higher value, that means if you say that C is 2, T is now if we go for 6, so it is 1 by 3, so 33%. Okay, that means now efficiency is increasing. Okay, so this ratio becomes 0.33, so it means the efficiency becomes 67 point something. Okay, so that is how this efficiency depends on this temperature ratio, or maximum cycle temperature. So as the temperature, that means ratio increases, the T increases, then our efficiency increases. So that is one thing. So as T increases, so we can just say as T increases, then efficiency also increases. So that is one thing. Okay, so the first thing we have to note down this. This is first important aspect. The next thing is suppose if you are increasing both, suppose C also increases, then T also increases, what happened? So that in that case what happened, our efficiency will be decreasing only, because C also increases, T also increases, then finally this ratio will not be changing or will not be decreasing. So then efficiency will be decreasing. That is the idea. If C also increases, T also increases, then what happened? Our efficiency is not increasing. Okay, so will not increase. That is one thing. Then another thing is efficient. The C should be smaller. Means C is the function of pressure ratio. Okay, if the C value is higher, that also we can see. If the C value is higher, then what happened? The ratio, this ratio will be that means increasing. That is the idea. Because instead of 2, suppose if you have a C equal to 4, suppose C equal to 4, then 4 by 4 by 6. So 4 by 6 nothing but 2 by 3. So 2 by 3 is nothing but again it is yes, that is nothing but around 60. Okay, so if the C increases, then automatically this ratio also increases. Okay, so this is the best example. Okay, so instead of 2 we are putting 4, then in that case what happened, our this ratio, whole ratio is that means decreasing. So because of that reason, okay, we can just say that the efficiency not the whole ratio is increasing, not decreasing. For instead of C, if you are putting instead of 2, if you are putting C equal to 4, then 4 by 6, nothing but it is 2 by 3. So 2 by 3 we know. Okay, so it is so the C ratio obviously it is increasing. Okay, so means decrease, C ratio obviously increasing. So if this ratio is larger, then obviously efficiency will be larger. That is the idea. So that means smaller pressure ratio only suitable for heat exchange cycle. What we need to understand from this, smaller pressure ratio, if you are going for the higher pressure ratio, then obviously this efficiency is decreasing. So if you are having a smaller pressure ratio and if you are increasing the T, then our efficiency increases. That is the idea. Okay, so that is what we have to understand. So based on this discussion, we can draw the diagram. That means a graph can be drawn. So how the graph looks? The graph looks like this. So this is just based on whatever we discussed, based on that only we are drawing this. So this is the performance curve. Okay, means efficiency versus this efficiency versus RP, pressure ratio. So for the symbol, this is 5, then 10, 15, 20. Okay, so then this also we can say that this is 0.2, 0.4, this is 0.4, then 0.6, then it is 0.8, then 1. Okay, so if the previously we have seen for the simple gas turbine cycle how this performance curve looks. So that is nothing but we can just see this one. So it was like this. So the performance curve for the simple gas turbine cycle. So it is something like this. It was something like this. Okay. So so this is for the simple gas turbine cycle. So now for the heat exchange, because we added the heat exchanger, because of that how this curve is going to change. This curve is changing something like this. See here, the curve is changing something like this. For this one, this is like this. It is for T equal to 2 and here we have like this. This is T equal to 3. Then yes, so this is T equal to 4. Then it is like this. So or even still we can make it still better. Yeah, like this. The slope is changing. That is what we have to understand. As T increases, the slope of the curve changing. Okay, so this is T equal to 5. So Now, okay, we can just see here as T is small, okay, smaller. So we have that smaller efficiency, and that too at okay, smaller RP pressure ratio. As the T increases, we can just see here efficiency also increases. Okay, so that is the idea. So I hope, okay, this is how this curve, that means the heat exchange cycle works, and the efficiency also plays the important role, that means to determine the performance of the heat exchange cycle. So yeah, okay, so this is what about the generally we can say about the performance aspect. So we have the, that means specific work output curve, that is similar to the heat exchange cycle, simple gas turbine cycle. Only efficiency curve changes. We have seen about the that specific work output versus RP. That curve is for the simple gas turbine cycle. That curve, and okay, for this heat exchange cycle also same. That means the specific work output versus the RP curve is same for both the heat exchange cycle and the simple gas turbine cycle. So this is only the major, okay, major changes, deviation we can say. So how the efficiency changes based on the T, okay, this curve, okay, this curve we have obtained based on this one only. For different okay value of C and T only, this curve has been obtained.